This is just a short video to explain logic gates, the symbol and the meaning. You need to know this if you're going to do logic gates. This is an AND gate. Symbol is like that, and it's represented with a dot, A and B. And you can only get an output when both of the inputs is 1. You get a 1 out, so you need 2 ones going in to get a 1 out. If you have a 0 and a 1, you won't get a 1 out, you get a 0 out. The opposite to that then is the Nand gate, and the difference is there's a little circle here at the end, and it's the opposite. In other words, if you have 2 ones going in, you're going to get a 0 out. We'll look at that a little later. And it's represented with A and B. There's actually a bar across the top. This is the OR gate, and the OR gate, it represented like this. You draw it like this, and it's A or B. It's got a plus symbol, A or B, and what that means is if either A or B are a 1, you'll get a 1 out, or if both are 1s, you'll get a 1 out. The NOR gate then is the opposite, and is represented with this symbol at the end. That's the difference. That's a NOR gate, and you write it A and B, but there's a bar across the top. This is the exclusive OR gate. It's drawn like this, and this is the opposite of an exclusive OR gate with a little circle at the end, and this is a NOR gate. Here we have the outputs for the AND gate. 2 zeros gives a 0, 1 and 0 gives a 0, and 0 and 1 gives a 0. Basically you need 2 ones to get a 1 out. The NAND gate is the opposite, 0 0 0 1, and here you have an output of 1 1 1 0. The OR gate then, A with the plus sign B, a 0 and 0 gives a 0, but anywhere you have a 1, either 1 1 or 2 ones going in, you'll get a 1 out. And the NOR gate is the opposite of the OR gate. You get a 1 out where you have a 0 0, and where there's a 1 you get zeros out. The exclusive OR gate, it's similar to the OR gate, except where you have 2 ones you get a 0 out. So you have 1 0 and 0 1, you get a 1 out, but you get a 0 out here for 1 and 1. And the exclusive NOR gate is the opposite of the exclusive OR gate. For 2 zeros you get a 1, and for 2 ones you get a 1, and where you just have 1 on the way in, you get 2 zeros on the way out. This last slide is basically a summary of what we've just gone through. This is the AND gate. X equals A dot B, dot being the and here's the truth table. And here's a NAND gate, and it's X equals A dot B with a bar across the top. And here's the OR gate, and it's X equals A with the plus symbol B, A or B. And here's the truth table. And the NOR gate is X equals A or B with a bar across the top. The exclusive OR then uses a plus with a circle around it. And there's the truth table. And here is the NOT, X equals not A. So when 0 is on one side, you have 1 and 1 and 0. That's it. We'll look at a few logic circuits in the next few videos, and also how you handle an equation, what part of it, the precedence. You deal with the brackets or a bar across the top first, then the OR, which is the dot, then the plus symbol, and then the exclusive OR. We'll look at that as well. Thank you for watching.